My content in this presentation is going to be specification of the fuel handling system, combustion process, deposition, boiler, and emission. Also, it's quite a wide range. Back to the basic stuff, I think that most of people may know that, or some people may not know too much about the properties. What's the coal? What is the property involved in terms of burning that fuel? So more likely, we need to understand all this sort of thing, moisture, ash, volumeter, sulfur, ultimate, calorific value, swell, ash fusion. I don't know if anybody knows this thing. Just roughly cover that. Of course, moisture, which is water involved in the fuel, you only can be able to drive that off above 110 or even set a higher temperature. Otherwise, you always have something involved. Okay. For the ash, for the residual stuff, when you talk about the ash content, we always want to talk about what is the condition you tested. For coal, STM standard 815 degrees for more than 2 hours. For wood, ISO standard 600 degrees. That's quite different conditions. So because the ash content is the yielding right at that condition, we need to specify the condition very, very carefully. Volumeter, which is very important stuff. The volumeter, which is the gas released out when the fuel in the boiler get to a temperature. Different type of the fuel, the releasing temperature is quite different. We need to understand that. So far, this is the emission stuff. Hydrogen, carbon, hydrogen, nitrogen, very easy. Getting value, easy. Swell propensity. Swell propensity, not many people know. It is a propensity come from bituminous coal. When the coal gets hotter, at a temperature maybe started to 500, 600 degrees, the coal started to swell up. Depends on the coal. For the bituminous coal, the higher rank bituminous coal is going to swell further. So that is why the coal from West Coast, Stockton, the swell index up to 9. If a smaller chunky coal, it can be probably that size. That is good for steelworks. Not very good at all for industrial boilers. When I was working for solid energy, the customer complained to me, no, you got solid energy just bad, you sold all the good costs to the overseas make money, or give us rubbish. I said, not quite right. That coal I give to you, you can not burn. Okay, this is swell. Ash fusion temperature, you just be aware ash can be melted, but it's not like water or ice melted at 0 degree single point, not really like that. They melted in a wide range. Because of the ash, it consists of a lot of different individual minerals. HGI probably is not very useful for everybody anyway. That's a hard growth. We call it hard growth grounding ability index. That is more likely used to evaluate the coal, how it's broken down or this sort of stuff. Good for pulverized fuel system. Size and size distribution. We need to have a decent size for the stock type of boilers. And bulk density, angle of repose. People forget that. What does that mean? Okay, just a bit more. So bulk density. We need to understand what it means bulk density. The bulk density is basically pull the fuel freely drop off into a container without shaking or compaction. So what is the density? It's quite different for determine on the size or the rank of the coal. For nickel coal around 650 to 850. Bituminous coal is heavier, around 800, 900. Angle of the repose. There's another very, very important parameter here. We're talking about when you form up a cone, that is going to be like that. The stuff is going to form up a cone like that. That angle from there towards the ground floor. That angle, we talk about the angle of repose. Okay, I want to just build that one here, you will understand why we want to talk about that one. The core size, grade, we talk about nuts, peas, chip, or fines, or select. That's the definition in terms of the field. Okay. For technical coal in Southland area, we have Ohio, Jikitimo, Kai Point, and New Well. This is the coal available in this part of the world. Ohio and Jikitimo they all are subbituminous coal. Kai Point is the same subbituminous C grade. New Well is a lignite. This is the moisture content ranging from 20, 28, 43, 41.3. That's the New Well. That's a lignite coal. H content these days. H probably Ohio is slightly higher than 3.7 now, 3.5 now. Heating value 23 for lignite down to 15 megajoule. Okay, angle of the reports, just beware for coal is in that range, not much change. This is why the hoppers were designed to a 60-degree angle. That's the angle of reports. For biomass fuel, that was very, very familiar. That's we take it from John Echoed hand eventually. This is pellets come from Nature's Flame originally, and the wood chip, Canadian wood chip. I think it's also in the area. They've Nangura, the sawmill provided wood chips here too. Hogger fuel basically a mixture between bag, wood shaving, whatsoever inside through the hogger. That's the hogger fuel. I took that photo actually recently. I was in Australia to come to do a boiler testing for Norske Skog. They do a 55 megawatts boiler, around 85 ton per hour steam. That you burn that hogger fuel through the boiler system. So you back to the typical. What is the typical analysis? The specific properties for wood waste. Wood pellets, because it's dry, pre-dried already, down to around 7%. H is low. Heating value 90 megajoule. Bulk density 700 around that mark. Angle of repose 32, 33 degrees. Seasoned wood chip, moisture coming down, maybe around 30% moisture. H start coming up. Heating value is around 30 megajoule already. Think about the bulk density, much lower. And angle of repose can be built up like a vertical without movement. Okay. For the fresh wood chip, moisture up to 60%, 55, 70, 60% is very normal. And heating value down to 8 megajoule per kilo. Again, weight is heavier, but the angle is much higher. Hogger fuel the same, very much the same. But the H content has been increased because of more bark being involved. With bark, that certainly is going to have more contamination from the soil during the harvest. The difference between coal and biomass, what's the big difference? You can always say moisture in the biomass could be higher, except the wood pellets. The H content in coal is much higher, okay? And obviously on the moisture, on the volatile matter, on the dry ash-free basis, if we don't consider moisture and ash, the volatile matter is around 40-50% for coal, 85% for wood. 85, no matter what is happening. Because of that higher, so fixed carbon, this is much higher in coal. Sulfur always lower in wood waste. That's why we got better sulfur, lower sulfur emission stuff. Calorific value, coal always higher, tended to be higher. Okay, much lower from wet wood. Bulk density much lower from wood. Angle was much higher, not easy to flow. Okay, ask questions.
Tell me the calorific value for the dry wood, please.
For the dry wood,
yep.
Depending on the moisture, if I come back to one slice, if you talk about 35% moisture, the high calorific value around 13 megajoule. Yes, it's moisture related. On the dry basis, for the clean wood, around 20 megajoule, put it that way. So whatever the moisture, you will always convert back to that basis.
Thank you.
Yep. I like that further questions on the way. It's too much information. Okay, on the dry ash-free basis, it's a very important figure. Volatile matter for coal, 55%. For wood pellets, no matter what the wood material is, on the dry ash-free basis, they are very much the same. On the heating value, for coal, for all heights, 30 megajoule. On the dry ash-free basis, for all sorts of wood, very much the same. You're going to see why we have calculated the figure here. That's the trend. Okay, it's very interesting. And for the volatile matter, as the volatile matter increase, which means the coal getting younger and younger, anthracite in that area, nickelite probably in that area, your biomass must be outside range over here. So volatile matter always, as the increase, the heating value always decrease. And the carbon, the fixed carbon inside the fuel, it keep dropping. For wood waste, your fixed carbon down to probably 10-15%. From originally anthracite up to 70-80%. Nitrogen and hydrogen, they are very steady right across the fuel grade, and the oxygen just increase. So when you're burning wood waste, you must be around that range. So the oxygen excess air required for combustion burning wood is much less because we got oxygen already. Okay, go over the combustion consequence sequence in the thermal balance. For different type of coal, they are going to release how fast. For nickelite coal, this is number 1 cube. For nickelite coal, okay, driving the moisture from that area, volatile matter start releasing at a higher temperature, 200 degrees, and then fixed carbon just burning off slowly. For the anthracite, which is the most hard to burn coal, very old coal, bituminous coal, number 3 cube, number 4 cube. At a higher temperature to release the volatile matter, carbon burning out, and not for anthracite because of the very high fixed carbon, take a long time to burn off. You can see the difference. The next one, for the with sawdust. We took an example from when I was doing a job for Mechanical Sawmill in Rotorua area. And we took example, we pushed this down for TGA balance, did the testing. For with sawdust, you can see the moisture come off very quickly around 100 degree temperature, and then carry on lost further a little bit more moisture. So the with sawdust, you can stay at that level around 58% is gone, which means the moisture content around 58%. And then after a while, around 200 to 250 degrees, this is the volatile matter started releasing. Once the volatile matter releasing around that temperature here, 300, 320, you only the residue inside the fuel down to 15-18%. This is the fixed carbon. So you can see that eventually in the process up to 450, 500 degrees all gone, finished, which means the combustion is finished already. So this is just to give you an idea the ignition temperature from peat. Oops, come back. Different rank of coal, the ignition temperature is different. That means related to the reactivity. So with lower temperature, if you have a flame can be started up, which means more reactive. For wood fuel, the ignition temperature eventually is much lower than that from coal. Okay. For another thing I want to talk about the flame temperature. As flame temperature is really pretty much determined by the heating value of the fuel. For the temperature, if we were burning coal, that's the flame temperature we have in the boiler, in the normal with the normal excess air, 1700, 1400 around that mark. If we burn wood waste, wood fuel, that's the flame temperature. around 1100 degree. It's a couple hundred lower, okay? And the next question is, why I want to put it here? Because inside the furnace, how much heat is being transferred to the water is determined by that formula. How much heat is being transferred is a transfer coefficient number, how much surface area available, and what is the flame temperature. The very, very powerful factor of 4. So the higher the flame temperature, more heat can be transferred to the water. Just remember that for now, okay? Talk about the general process in the boiler. This is a really hot boiler, right? And then what is the input? So the first of all, we have water get to the boiler, and they get a coal or wood, what is fuel, into the boiler, and then with air. So that's the input, the balance. Okay. Output, of course, water is coming from steam. Ash is coming from fuel. Oops, come away. And you have a flow gas get out from that process. So in that process, it's always associated with coal handling, burning, ash deposition, and emission in that process. For the handling system, in the traditionally, what is the system available in the country here? The hopper or bunker with auger, okay, that's what we got. Conveyor belt, dragging chain, bucket elevator to put the coal up to a higher level, and we have a pneumatic feeding. That is quite a typical, very commonly used for vehicle boilers. So that's what we got in the country. And for the wood waste, you use a molten floor. Why we don't use the traditional one for wood waste? Simply because of the angle of recourse. Because there's no flowability available. So we have to use a different type. So in the combustion process, there inside the boiler, that is the sequence: drying, volatile metal releasing, ignition, and carbon burning out. The drying is get the moisture removed first. Without a proper drying, your moisture not drying off completely, you get no fire at all. So next one, the volatile metal releasing. Once the gas started to release out from wood, it's going to build it up in somewhere in the chamber. You have a sparks available. Boom, that's the fire started. And towards the end, just the carbon slowly burning out. How we're going to determine a good combustion? We always say, if we go to the combustible gases is low in the gas, the unburned carbon in the bottom ash or in the fly ash, very low. That's it to make it how can we evaluate good or bad for combustion. How we're going to achieve good combustion? We always say 3 T's. That's a typical 3 T. What does that mean? We need to have a good temperature. Without a temperature, there's nothing going to happen. Longer enough time, and good turbulence. That's the 3 T. So if you put a big pile of coal or biomass here without the temperature, just stay there for a long time. So you need to have decent temperature available. To achieve a good burning out, you need to have a longer enough time for the particles or gases to be able to experience inside the combustion chamber. This turbulence basically just created as the route for the particles or gases travel around the chamber, make a longer time available. So if we do energy balance for boiler, the same boiler again, the energy input, the only heat input is from wood, from a coal, that's from fuel, okay? But the energy output, what we have is the heat associated in the water or steam. The heat involved in the hot flow gas, how much heat has been put there. So inside the flow gas, We have heat in the dry flue gas, how much heat in the associated with the moisture. That moisture including moisture from film, moisture from the humidity, how wet today is very wet, more heat being generated, wasted from to the chimney. Heat associated with the combustible gases. Heat in the bottom edge, how much unburned carbon in the flash, this was it. Because the edge will always discharge the edge to somewhere with a higher temperature above the room temperature. That is going to lose some heat as well. That's another part of the heat loss here. The last bit is the radiation. Because the insulation may not be 100% right, so some heat is being emitted from the body around the boiler. So that is the whole energy balance through a boiler. Input is the only one, output is the 6 altogether. So if we do a heat assessment, we have to assess all the whole lot to get it right. To achieve a good boiler efficiency, we need to reduce all the heat losses. Your typical boiler efficiency here, I want to talk is for coal, you're looking for a normal bituminous, sub-bituminous coal, we're looking for around 80%, based on the gross calorific value. Sometimes people confused. If I talk about the general combustion efficiency, combustion efficiency can be up to 99%. If you look at boiler efficiency, you have to talk about on the gross value or on the net value. On the gross value, about 80. On the net heat value, can be up to 92, 93. It's different. But in the country here, we always talk about gross. The typical boiler efficiency for burning wood for the lignite, like a new well, it is about 75%. You can achieve that because of the more moisture inside the coal. If we talk about the typical boiler for wood waste, if we're burning wheat wood, okay, 55–60% the moisture is going to be about 60% only. That is the efficiency you're going to face. So when we're dealing with the solid fuel, including coal or biomass, we always have a problem, clinker. Clinker is the ash melted at higher temperature. The temperature around the grate is too hot, it's too high, so that the ash cannot be survived, get melted, soft, stick together. How easy to get this clinker, which means that it's really dependent on the mineral or under the combustion conditions. But in general, in the clinker formation, normally you have big particles, ash particles, joining up with a sort of liquid phase started from at the beginning. And in the liquid phase, it's very, very rich in sodium, potassium, iron in the phase. That is what I did when I was doing my degrees with an XRD scanner. Did the testing analysis for myself. How to minimize the clinker state formation? You have to, if you're burning very intense, and the combustion temperature is going to be too hot, it's obviously you get more chance to clinker. You need to avoid the localized hot spot so that the temperature can be more even, the heat being dispersed properly. It's better to create an oxidized condition because that in the oxidized condition, iron tend to be iron 3+ rather than 2+. The iron 2+ oxide, that the melting point about 100 degrees lower than the iron 3+ in the oxidation condition. That's why we wanted to have a decent access here. So even yesterday I wanted to arrange meat there that can complain, oh, I got so much clinker. So when I put my analyzer into this boiler, only about half an hour, I got, oh shit, your oxygen down to 2%. The clinker is in a black color because the heat not being pushed away from the grate, not enough excess air. To manage the clean surface. Oops. Sort blowing with a probably good match design between the boiler and the film. And another poor ash deposition problem is the falling. Falling it is that the ash particles deposited on the water, on the tubes. It's not on the grate, in the tubes with the convection bank area. Basically, that is started by the condensation of some minerals. More likely, it is sodium oxide, sodium sulfate, sodium chloride. This is the typical, if you put a water tube there, the gas flow coming that way, more particles is going to be associated like that. For my weight show the shape, and you can say that is, I took the photo from one of the boiler in Timor. When you have a falling problem, you get a white skull along the tubes. That white skull can be corrosive if you do that for a long time. Minimize the falling, the options, solar blower, remove the ash with the solar blower. You can use flue gas recirculating, trying to put a part of the flue gas back to the boiler, lower the temperature down to minimize the vaporization of that sodium condensation. Or you change your coal with a lower alkaline material inside with the sulfur content. That's the options. Okay, quickly cover up some boiler available in the country. That is the boiler from combustion. We have a sort of type combustion in the air, combustion in suspended way, in fluidized way. So the boiler type on the near state, basically it's a stock type of boiler. On the suspended state, power as the fuel boiler. That is the boiler in handling power station, coal-fired power station. Fluidized bed, that is associated with the fluidized state. FBC or CFBC. I saw that the boiler at Finnegan. It's a good one. I had a test on that boiler, running very, very well. So the popular stock in the country here, stock type boiler, we have underfit stock boiler, chain grade, cooking grade, sprinkler, and vehicles. So that is summarize what is the boiler. No matter what your brand is, actually you are in the one of the range, one of in the 5 categories. Underfit stock boiler. This boiler has been widely used in the smaller industry or schools, hospital, small hospital. Section the boiler is fake bunker, send the coal through the water into the retort. And there's another section of boiler, same principle. Okay, the bunker here, the boiler here, the section of boiler. When you see that picture, is very, very popular. That actually comes from Tamek, and that is the boiler and the cylinder type of boiler, fire tubes. The tubes, the flue gas passes through the tubes, get out of the chimney. That one is you can make the boiler slightly bigger, and very importantly, the coal hopper is on this section, and the boiler is going to stand on the top of that section here. The coal feeds through that retort here. Combustion air supplied by that fan pushes through here. Some of the air comes through the hole for burning. A part of the air pop up through the 4 nozzles as overfire air, which is very, very important to minimize the smoking. Another thing I wanted to mention here is people forgot to, for maintenance here, put a balance pipe through that, take the air pressure from here, seal any gas possibly go into that way. It's a very, very common problem here. Some people forget that. Okay, that's the detail on the fact. Another type of the chain grade boiler. chambered boiler is the hopper come from here through a guillotine gate, so to level how much fuel is going to come in, and the coal burning there, start the ignition in that area. That is the front. That is the firing arch. For chambered boiler, the arch is the only heat source available to join the fuel for coal or wood. If you have more surface heat available, you can burn a lower ranking coal or wood waste for chambered boiler. That's its condition. It's very, very restricted. On the chambered boiler, the grate is like this. All the links being joined together slowly, and if the temperature on the grate is too high, these links can be jammed each other, can cause a jamming problem, called a stock-up storm. It's not very good for that way. Okay. This is one of the boiler talking in Ashburton area. The chambered boiler was equivalent with the two chans to share on the same boiler. Another type of boiler is a rimmed stoker boiler. The coal is being sent to pushing by the rim out in, push the coal into the stoker. The fire bars is walking that way, reciprocating way, and take the coal into the boiler. So that was probably easier. That the fire bars, the coal is coming from that way, pushing by the fire bars are open this way, so push the coal forwards. Yep, because this boiler originally designed for burning bituminous coal, so that's why I gave a name the coking boiler. Because because bituminous coal has such a propensity, and but because of the movement, so that the hot amber can be available to provide the drying for the initial fresh fuel, so that the boiler can be able to burn anything really. Sprinkler boiler. Sprinkler boiler is probably very, very common now because of the boiler size being getting bigger, and the coal come to this way, drop that towards a sprinkler, a rotor, so feeding through the coal onto the grate, combustion air coming from the bottom. So that is the way. Like most of the boilers in this area, Frontier in Udendale, 4 boilers are on this way. One of the boilers in Novo plant, the other for the big plant. Yeah, it's the same thing, just a couple of them more. Oops, yes, out very quickly. Yep, that's the Frontier boiler anyway. Another type of boiler is a viscous boiler. The viscous boiler, the coal comes from the water on the top, drop onto the chamber, and yeah, it's very, very common in New Zealand. Viscous boiler. It's a packaging boiler, small, pretty much you got it, plug it into it, get it into it very, very quickly, install it very quickly. Okay, then you get a boiler, barbecue boiler, get a because yeah, the chamber of the boiler. It's a nice group in Ontario, Belfast as well. That is another John Thompson boiler at Whakatane. I want to use that one because that boiler burning coal, eventually they introduce hog fuel, wood waste, through that point. So open the arch up, put the hog fuel into that boiler to carry on, because the hog fuel is so wet, not easy to get it ignited. So they use the coal to start the fire, provide the heat, so the weight of wood dropped on the hot base. That's the only way to burn. Another because yeah, chamber boiler anyway. Okay. That is the summary for all this boiler, what it can be done, what's the grade. Different boiler has a different size, capacity, this sort of stuff. In general, underfeed stoker is much smaller. Viscous boiler, 1 to 6 megawatts, it's cheaper boiler. Chambered boiler, you have a more movable sort of mechanism parts inside, and the ignition is the key, just beware. Sprinkler boiler can burn anything really, because the coal or fresh fuel landed on the hot bed. The not heat available for drying. So use biomass fuel for the new heating plant. If you start from a new heating plant, that's fine. You just consider use a proper handling system because of the physical properties. Design a proper fire regulation area or space, and design a proper boiler fillets so that the capacity not compromised. Okay, proper design on the air distribution system. For retrofit, if you put a biomass boiler on the existing boiler, we have to consider all this sort of thing. Continuous feeding to the wood boiler without a breaching problem. You have a reasonably good ignition available. You can achieve good evenness bed for combustion. Ensure there is a secondary air available. Okay, heating plant, you have redundancy. Why I say that? Because of the heat transfer determined by the flame temperature, and the temperature from wood waste is going to be lower, so that your capacity can be compromised. Yep, for retrofit, why we wanted to have a continuous feed? Because of the angle of the report from biomass. You should have plenty capacity for feeding more the stoker. You have extra capacity available to be able to feed more volume of the wood. Otherwise, your heating input is not going to be the same as coal, because of the bulk density is much lower, with much lower heating value from wood waste. You wanted to have a good regulation, because the wood waste tended to have a higher moisture content. You needed to have a decent heating source available to be able to get the wood started. The bed evenness, if the bed is uneven, what's going to happen? The air is going to go to where it's less fuel, so that you got a very high unused airflow, result lower boiler efficiency, and blow some of the ash particles towards the chimney, resulting in higher particulate emission. The boiler performance side, burning wood waste the efficiency can be slightly lower, and you need to consider all this delivery system, how much volume you. And then you need to consider that capacity reduction could be a case. The ash generation from wood waste is going to be less anyway. For coal firing with coal, again, you need to have the system can be able to handle not only the coal, but more importantly, handle the biomass. It sometimes can be a separate feeding system required, or separate stoker required as well. And you need to have a way to maintain an even bed for the grate to fill it, because biomass can be much faster to finish the burning, because of it's more reactive, because of it has much higher volume matter. The burning once it get going very fast. So the suitability to burn wood waste on the existing boiler. So I categorized here for the chunk with the boiler. We tried at a different site. I said a no. Only reason because you are going to face chunk with the boiler for wood pellets or dry wood chips can get it started, but the overheating of the grate could be an issue because of the lower ash content. No such insulation available to protect the nicks. For sprinkler type of boiler, I say yes for wood waste, but just beware, make sure you spread the fuel properly. For rim stock boiler, yes, you can do it. For underfed stock boiler, Yes, just beware on the feedstock boiler, the water, when you're dealing with wood waste, the air permeability is much higher, so that the gas or air, hot gas from the combustion chamber can travel back towards the bunker way. You need to consider anti-burn back system safety devices. For vehicles boiler, certainly that's not a problem at all. The boiler is configured in that way, can burn anything. But just be aware the slight reduction on the capacity. On the environmental side, burning wood waste is going to be better for the particulates mainly because of the lower ash content. Sulfur dioxide is going to be benefit. CO2 emission from burning coal, you're around per kilowatt hour, 400 grams for burning coal. But for burning wood, because it's considered as renewable, so around 12 grams. That's much, much lower. That's why I want to go that way. I think the conclusion probably, you know what I wanted to say now. Biomass can be used to substitute coal. Coal handling system, we need to consider that it's going to be able to handle biomass or not. The boiler stocker should have enough capacity to be able to handle the large volume. The boiler should have a way to provide sufficient heat for drying the wood fuel. The boiler should have a sufficient secondary air. Because of the high volatile matter again, you need more overflow air available to attack that gases emitted from fire. Boiler capacity can be slightly reduced, better emissions. Thank you. Let's go. Easy.